How do I solve these by graphing? Can I graph them as they are? That is correct. So we need to put in the form of y equals mx plus b. So you need to get y by itself for each of those. Okay? What?
Because like when I was looking, I got elimination, and all of them are going to be 0. If we did elimination.
Are you sure?
Where are you going?
Okay. I thought that. All right, let's go, people. We don't have noodles time. My goodness. Someone wrote a bunch of biblical scripture on the back of this ruler. Oh my goodness. I mean, goodness. You got one. You got two. Okay. All right. So, guys, let's put this in y equals mx plus b form. Does anybody need a little help to get started with that? Why don't we do the first one together?
Yep.
Okay, that sounds like a plan. Y equals mx plus b. So I'm going to start with the first one, 2x plus 3y equals 9. I'm putting this over where I have some space. I want to get y by itself. So what would I need to do mathematically? That is correct. And guys, let's keep the phones away, please. 3y is what you have left. Can I combine this 9 minus 2x? No, they are not like terms. So I am going to put the x term first because what's in front of the x is my slope. And then put plus 9. I want to get y by itself. Right now y is being multiplied, so I'm going to divide by 3 and get y equals negative 2/3 times x plus 3. So what is my b or my y-intercept here? 3. That is the y-intercept. And my slope is the negative 2/3. So when you are graphing, you always start by plotting the y-intercept. 1, 2, 3. And from that point, I am going to go down 2 and to the right 3. Down 2, right 3. 1, 2, 3. Down 2, right 3. 1, 2, 3. And take your handy dandy ruler and let's make a nice little line like so. And remember, since it is a line, it continues forever. You should put some arrows on the end points. And that is our first one. Huh, that's too bad. Oh, maybe if I go like this? No. Maybe if I do this? Oh, okay. All right, so then the second one, if we graph, is negative 4x minus 6y equals negative 18. Want again to solve for y, so let's move that x amount. How do I move it? We want to add. It's negative 4x now, so I want to add 4x. I'm sorry?
They're like the same numbers, but like the negative plus sign on the switch.
Aha. So y equals, I get negative 4 6x. Hey guys, can you stop the talking? Thank you. So negative 4 6x plus 3, well that's kind of similar. We could simplify that slope. Great. Thank you. Do you need me to sign that?
No.
Okay. Thank you. So I'm sorry. What were we saying? Yes, negative 2/3 plus 3.
No, this should be -3. But
No, because we had negative 18 divided by negative 6. So it's negative 2/3 x plus 3.
wait,
Hey, what do you notice about these two equations?
the same.
They're exactly the same, which means their graph is going to be...
We just put a coefficient on that difference.
Coefficients are different? No. They are exactly the same. Okay, now this is what we are observing just while we are graphing. Okay, so really it's one line on top of itself. They are the same line, is what you said. They are the same line. So if they are the same line, what is your solution? Remember, the solution is where they are intersecting. No? Well, that's your y-intercept. That's not your solution. It is a solution. What do you mean by 6?
Well, we need to graph the other one, so.
We did graph the other one. Red line on top of blue line. That's what I tried to do. So there's the same line graphed on top of itself. So how many solutions do I have? No. I actually have infinite number of solutions because every line that is on there is on top of itself, right? It's one line on top of itself. And you can, every space you have in between two visible solutions like this, you can do half and say, okay, there's half the distance. That's another solution. You can do a half in here. There's another solution. Then you can do the distance of half of that, which would be in there. And you can do half of that. And it's just over and over and over. And these are lines that go on forever. So that's why it's infinite number of solutions. Yes. Give me just a minute. Now, that just takes care of the graphing part. We did not try to solve this algebraically, so let's try this algebraically, and I'm going to do this at the bottom. 2x plus 3y equals 9, and negative 4x plus 3y, negative 4x minus 6y equals negative 18. Remember, we want to be able to add these together. So we already did the graphing. What are my other two methods of solving a system of equations? Elimination or, and do we have y equals or x equals to make it easy? No. So let's go elimination. And what do you want to eliminate, the x's or the y's?
You can eliminate all of them.
We can, but let's choose one first. The y, because I'm asking. Oh, Miss Thenie. Yeah. So we are going to try to get rid of the y. Since this is a negative 6y, I want it to be a positive 6y to eliminate. So what do I need to multiply this by to get 6? By 2. So everything gets multiplied by 2. And I'm going to rewrite it below. So 2 times 2x is 4x. We already know 2 times 3y is 6y. And 2 times 9, positive 18. So now I'm adding these bottom two equations. I'm going to cancel out the y's. The problem is, what is negative 4x plus 4x? 0 equals, what's negative 18 plus positive 18? Is 0 equal to 0? Yes, that is true. What does that tell me about my solutions? You have an infinite number. So if you have a true statement like 5 equals 5 or x equals x or 0 equals 0, that is absolutely true, and that means you will have an infinite number of solutions, which we already found from our graphing. Okay? All right. So now let's turn the page. I am going to have you work on page 32. We have two new equations. Graph those. Find their solution. Also do it algebraically. Okay? I'm going to give you about 5 minutes just to see how far you can get in 5 minutes. And then we'll come together. But everybody, try to work on these on your own. This is what you're going to be doing tomorrow. Tori, that was you, right? Now, people looking down at your phones is not what I would call working on the problem. Come on now. You're hurting my heart.
You're breaking her heart.
You're breaking my heart. No, it's just Miss Baby. 2, 4. Tori, what's your last name again?
Carter.
Carter. I would not have gotten that at all. All right, here you go, Miss Tori.
Yeah, who are you talking with?
You.
Come on, Mari.
Was that a Madagascar reference? Yeah, I was right.
Was that what?
A Madagascar reference?
Yes, it was. Let's move it, move it. Did you like that?
Mm-hmm.
Did it make you think like, oh?
I laughed. What's noise? And it's sunshine? No, it's
So how are we doing? Are we getting our graphs? Okay. All right. Has everybody taken the test in here? I think so.
Did you get mine?
I did not have it as of this morning before school. When did you do it?
I did yesterday.
Yesterday? Who?
Mr. Smith's in HR.
Oh, yes, I did. So I think she brought it to me. Yes, yes. I don't have it graded yet, though.
I got a question. When it says algebraically, that means like.
That's using either elimination or substitution, doing algebra to figure it out.
Okay.
Okay, did we make some headway?
Yeah.
All right.
Yeah.
Shoot. All right, so when you graphed those two things, do you need me to go through those just to check? Maybe? I think I can do this pretty quickly. What did you notice? Yeah, what do you notice about the lines? They are two parallel lines. What makes something have two parallel lines? What has to be the same? What has to be different? Do you know?
The different is our y-intercept.
The y-intercept has to be different, and what has to be the same? The slope. Excellent. Did you remember that from before? Kind of? Your past math classes? All right, so if I'm going through this quick, negative x plus 8 divide by negative 2, and I get y equals 1/2 x, so there was no number there, so that's a 1 minus 4. So this is my y-intercept, 1, 2, 3, 4, and this is my slope, which means up 1 and to the right 2. Up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. And if I make a nice line right there, so that is the first one. The second one, 3x minus 6y equals 6. I need the y, subtract 3x, subtract 3x. Negative 6y equals, I can't combine those, right, Rowan? So negative 3x plus 6, Rowan, please put that away. Divide by negative 6. Y equals, negative by negative is 1/2 x minus 1. So different y-intercept, same slope. That's why they are parallel. So up 1 over 2, up 1 over 2, up 1 over 2. Let's draw a nice line. Da, da, da. So, two parallel lines. What is my solution then? 2 or 1? So when we are looking for a solution, guys, let's focus in a little bit. When we're looking for a solution, we are looking for the places where they are going to do what? Intersect. So where are these two parallel lines going to intersect?
None.
They are none. So how many solutions do we have? No solution. None. Okay. So the solution, again, is where they intersect. Because they're never going to intersect, there is no solution. Or, if that seems like a lot of writing to you, you can make this symbol, which looks like an O with a diagonal through it. That is the null set. That means there is no solution. Okay? Now, did you try to solve it algebraically? Yes? No? No? Yes? Not yet? All right, well, let's do this. X minus 2y. I'll do that one in green. So somewhere on your paper, x minus 2y equals 8. And 3x minus 6y is equal to 6. Okay? So again, we don't have the y equals x equals. We don't want to use substitution, so probably going to use elimination. Let's say I want to eliminate the x's. What would I multiply that top equation by? What would it be? Yeah, -3. So -3x plus 6y equals -24. They cancel out. But wait a minute, what is this -6y plus 6y? What do I get when I add those together? 0 equals, and what is 6 plus -24? -18. Is 0 equal to -18? No, this is false. So that's why this means no solution. Because that is actually false, Tori, that means no solution, okay? Any questions on that? All right. Just enough time for the last one. So, page 33. Want to take a guess at what this is going to look like? Say it again. They may intersect. That could be true. So, -x plus y equals -2, 3x plus y equals 2. Graph both of these. Tell me what you notice about the lines, and do that. Also solve them algebraically if you can, okay? I'm going to come around and see if you need some help. Who needs some help? All right, see if you can graph them. You have to graph, and y equals mx plus b. Okay, y equals mx plus b.
One. -x. 1.
Then do it.
Stop messing. No, stop messing with me.
How should I go?
I don't like that.
I don't like that. Good for you. I'm sorry to hear that.
Wrong with me, so.
It's just because do this one. Do the
Yeah.
bottom one. Do 3x.
The positive x or negative? Yeah. Do not say over here. Any questions?
And then
Need some help? Okay. Put that on the way. Eli, I know you heard me. Put the phone away.
I'm changing my phone, but
You're what?
I'm changing my phone.
Oh my gosh. It's always something. All right. So, can you graph that? Can you graph one?
Oh, no, you can't grab it.
Well, you have to be able to. So I want to get this one by itself.
No, I thought you did.
I've been had it.
Oh, right, yeah, not as it is. Correct.
Shut the front door. I do the
How
other.
you doing, Mr. Williams? You all right?
I think so.
Okay. I know. I would say, how's it going? Or, are you all right? Well, I'd like to think so, you know. So tomorrow, as I said, you'll be doing some more of this. Again, I will not be here, no plugs. Also, I will be giving you that fun little one worksheet that matches your energy with the energy of someone else, and that will create partners for an activity next week, I think.
I don't let us.
Mm,
I think that'd be a great idea. Yeah.
Sometimes that works, sometimes it doesn't.
Well, we should try and see how that goes.
Well, since I'm not going to be here, I think it's probably best to give you this sheet to work on.
I won't.
Oh, you're not going to be either?
No, I have a dentist appointment.
And you specifically picked this time?
No.
Oh, okay.
That's
Okay. Oh, okay. Okay.
Nah, something else sound right, huh?
You get it algebraically, or you just are getting it in Y form? Minus Y. Okay. Yeah.
That's that one.
Oh, and then the other one. So yes. Grab those puppies.
Grab those puppies.
Yeah.
Yeah, yes, grab.
I did.
Did I forget to set the timer? For the second one? Or for what? Oh, algebraically?
Yasmin, let me tell you what happened to me yesterday. So I went to the gas station, right? And I left my car running. Because I'm like, nobody's gonna.
Why would you leave your car running at a gas station?
Because I was running in and out. So I'm like, nobody's gonna get in my car. I'm already.
So somebody got in your car?
Yasmin, I went to my car, watched this old lady sitting in my passenger seat. So I said, hello,
You're lying.
I'm so serious.
So if
She's
you multiply
sitting
negative
in
times
the
negative, that would give you a positive, which doesn't
So I'm
really
like,
cancel them out.
you're in the wrong car. She's like,
Because
oh,
this is the
oh,
3.
am I? I'm
So
like,
you want to
yes.
multiply this
She's like,
by just
oh, okay.
positive 3.
She takes her time.
No, that would have scared me.
She takes her time getting out my car. She's getting out so slow. She's like looking around, getting out so slow. So I'm like, bro. She's like, I thought this was my car.
All right. I think I forgot to set the timer, but Tori, hang on. Let's do the math, and we'll do it at the end, okay? So, negative x plus y equals negative 2. We need to put that in y equals mx plus b form. That's easy for me to say, not. So, add x, y equals x minus 2. If I were to graph this, there is my y-intercept. That's on the y-axis. So negative 2, 2 spots below on the y-axis. My slope, what is my slope? There's nothing in front of x. 1 over 1, yes. So that means I need to go up 1 and to the right 1. So up 1 to the right 1, up 1 to the right 1. So every diagonal. Okay. And let's make our nice pretty line. And don't forget those arrows. This line goes on forever. And the next one, we have 3x. Oh, I don't need to write that. I can leave that there. Subtract 3x. And y is equal to negative 3x plus 2. That means I am starting at 2 for my y-intercept. And I am going negative 3, that is down 3, and to the right 1. So from that spot, down 3, 1, 2, 3, to the right 1, down 3, 1, 2, 3, to the right 1. Yeah, I usually like 3 points at least. I think that makes a nice straight line. You really only need 2. 3 makes it really solid. All right. So those are my lines. What do we notice about these lines? Intersect in 1 point, or intersect at 1 point. Okay. And what is that point that they intersect at? 1, negative 1. Now, if we would solve these algebraically, which hopefully you did, you will get the same thing. One solution. So when you have intersecting lines, you have one solution. When you have parallel lines, I should do this in a minute when I'm not writing all this down. So add these together. Again, I don't have a y equals x equals, so I would probably choose linear combination or elimination. I'm going to multiply this by positive 3, which gives me negative 3x here, 3y here, and negative 6 here. Add these together, and x's cancel out. I always box it and cross it out. You don't have to do that. Y plus 3y is 4y equals 4. So y is equal to 1. And if y is equal to 1, I need to take that and substitute it back in. That is a step that a lot of people forget about. Don't forget. Did I miss something? Oh, it should be negative 4. Thank you. Piece of candy for you. Because now I finally have candy. Y equals negative 1, which is good. So now substitute that in. Let's go to the first one. Negative x plus y is negative 2. So negative x plus a negative 1, that's where I substituted in, equals negative 2. Add 1, add 1. Negative x equals negative 1, bless you. And so divide by negative 1. X is equal to 1. So solution is 1, negative 1, which is what we had before. Any questions about that? So we're not going to do this little quiz today, but somewhere, maybe on that last page, you might want to put something like this. So if you have intersecting lines, how many solutions are you going to have? One solution. And it is going to be a point, an x-coordinate and a y-coordinate, correct? If you have two parallel lines, how many solutions do you have? 0, but don't put 0. I guess you could say 0 solution. You should say no solution, or you can put the null set. And what's my other one? If you have one line on top of the other line, how many solutions is that? Infinitely many. Infinitely many. Infinite number. Okay? Questions about that? Now, before you go off, I want you to try to do on Canvas homework number 1, and I would love to have that due by Friday. Now, that can be Friday at midnight, but I think most of you are capable. Try to get that done by Friday. That way we're not like doing our homework at the last minute of the module, okay? And again, our project is going to be in place of the assessment, which is a test, okay? If you guys can bring up your rulers, because my other classes are not going to be using those, and they'll be hitting each other and all those kind of things. So